All right, so let's go through three-step process. Oh my lord. All right, F prime, so please make sure you notate. Lafika, give me the first step for number 1. All right, so we get negative sign. Timon, what should I do next? Leave the inside the same. Thank you, Nathan. What's next? Multiply by it. Beautiful. All right, so e to the x. All right, number 2. Take a look. Now you're going to give me the physical answer. Annie, what is the first part? 1 over, and you actually did 2 parts. That's actually just the derivative of the out. I know it's hard to not. Noah, what should I do next? Leave the inside. Beautiful. Ramsey, last. Multiply by the derivative of the inside, so I'll put that right here. Okay. And then number 3, right here. I'll get there in a second. All right, so I'm going to come down here so I have a little bit more space. Danny, what should I do first? Take the derivative of the outside. There we go. All right. Laura, what should I do next? Put the inside in. There we go. Joshua, what's last? Beautiful. All right, so we got, which we have 8x minus 8. All right, so I'm actually going to leave them unsimplified, except for this one, because you're going to see a problem later that's going to look similar to this. So I have to multiply by 8. There were 3 steps, right? So let's go back to here. How many chain rules do you see? How many insides do you see? 1. So you do the derivative of the inside once. Did I do d out, leave the inside, derivative of the inside? Yes. So then your question was, do I need to take another just d in? The answer is no. Okay, count how many chain rules you have if that gets confusing, because it does. Count how many chain rules you have. If you know you have 1, then you're only doing d in once. Good? All right, so the s prime of t is cosine of t over sine of t, and yes, that is going to give me cotangent. And we're going to talk about that in a second. So what I want you to see is when you do a chain rule for every single one, and it makes sense because we said it. Oopsie, that's not a D. All right, so for every single chain rule we've done, here's the inside, and then you ended up multiplying by your d in for every single one of them, okay? So if I want to do the integral of this guy and undo, that's where the product's coming from. Okay, so I just want you to keep that in mind, because when we start doing the substitution, you'll understand why this is going to work out. So just keep that in mind. That's it. All right, there are going to be 2 more that I want to look at, which are these 2. So your d-ins were always multiplied. These derivatives are a little bit tricky, because if you multiply by 1 over x, do you understand that that's the same as dividing by x? So let's say your inside is ln of x, then your d in is going to look like divide by x. It doesn't look like the other ones. It doesn't look like it's being multiplied. Okay, so number 5. This is not on your paper. You actually have to write them. So x to the 1/2. And you get this guy. But usually when we write our problems out and you're given your problem, there's no negative exponents. So do you see how if this was your inside, then the derivative of your inside would actually look like divided by 2 root x. So it's tricky because they don't look like they're multiplying. So pretending that these were your inside functions, you would actually be dividing by x. Dividing by 2 root x. So I want you to just keep that in mind. I'll come back to this when I show you a problem that this happens, okay? All right, so what I did for you was kind of do a quick summary in case. All right, I'm going to say the steps. We're going to practice the steps a good 3 times. But if you forget what the steps are, you have them here. And then also the video will walk you through the steps. Because that's what substitution is. There's a bunch of steps involved. And once you get that process down, the problems will get harder. Trying to identify what to substitute gets a little bit harder. Okay? Tonight's homework, you're going to not identify anything. They're going to tell you what U is, and you're just going to do the process. And then tomorrow night, you're going to figure out on your own what U is and do the process. Okay? So I want to take example 1, which is this guy. The integral of x plus, I can't remember what number it was. 2 to the 5th. All right. So this problem that you have down there, we're going to do 2 ways. Because here's what I don't want you to forget. Did we learn how to do integrals prior to substitution? Why are people guessing on that answer? Did we learn how to do integrals prior to substitution? Okay. That means you will still use those skills. So you will get a quick quiz on substitution. And what happens? Now you want to try substitution with everything and anything you see. They're not all substitution, okay? Just like when you learned product rule and you learned chain rule, you don't use them for everything. You just use them when you need them, okay? So I'm going to do this one the old way, because you can, and then I'm going to show you substitution. And then you're going to say, why would you ever do substitution? That's such a long process. It's because the short way only works sometimes. So we're going to reverse the chain rule, meaning we're going to do this 2 different ways. Yes, you'll have enough room. So reversing the chain rule says that you're allowed to reverse chain rule. Oops. Only when the dn is a constant. That's the only time it works. And we're going to have a lot of functions where our inside is not a constant. So I check that. The derivative of my inside, how much is it? Just 1. 1. 1. So we're going to do exactly what it says. So we know that when you do your chain rule, the inside stays the same. So that inside better still be there. That makes sense to everyone, right? We were pretty good with that. What do I do with the power of 5? We're doing an integral. Be careful. Add. We add 1. And then what do I do with that? Divide by it. So our dn was 1. What do I do with the dn? Instead of multiply, we divide. So we're going to still write it just so you have it in your notes. All right, so I have an answer. There's my answer. And then I'm going to do substitution. You're going to say, I don't want to do substitution. It's so long. It's so why? It's because I want to show you the skill with an easy problem. Then they'll get a little bit harder as we go. All right, so here is substitution. Same concept. You're going to start with the inside. Okay? So my inside in this problem is x plus 2. So there's your first step. You're going to have to figure out what your u is. Tonight you won't, because I'll tell you. There's step 1. U is x plus 2. Step 2. Find its derivative with respect to the variable. In this case, it's dx, so we're going to write dx. What's the derivative of this guy? 1. All right, so step 1, find u. Step 2, take its derivative. Step 3, solve for the dx. Most of your problems will be in terms of dx. Solve for dx. So here we go. I'm going to move the dx to the other side by multiplying. Okay. So step 1, identify u. Step 2, take its derivative. Step 3, solve for dx. If you like having the steps right next to them, write it down. All right, so now you're going to do 2 substitutions. 2. Substitution number 1 is the u. So here's the u. It is x plus 2, so I'm going to rewrite x plus 2 as a u. The 5's still there. And then you see that dx? There's substitution number 2. I'm going to replace it with the du. Dx is the same thing as du, so I write it down. Now, let's pretend all of this stuff never ever happened and all I gave... Whoa! All I did was throw my pen. All I gave you was this problem. Pretty easy problem? U to the 5th. Can you take the integral of u to the 5th? Yeah, pretty quick. U to the 6 divided by 6. What you'll notice, chain rule's gone. There's no chain anymore. Turn it into a straight power. That's what substitution does. It takes away the chain. It can also take away some products, and it can take away some quotients. That's what it does for you. Process looks a little long, but I'll show you later. You can't avoid it, okay? So that answer, if you wrote that, I would mark it wrong because there were no u's in my problem. So go back and put your x's back. So instead of u, what am I going to put in? X plus 2. You got it. And if you want to put 1/6 or over 6, they're both going to be correct. So there's the process. That's what you're going to practice tonight. You won't have to figure out your own u. All right? So let's look at number 2. All right, so this one again. The inside, 4x minus 1. Derivative of the inside is how much? 4. So you could reverse the chain rule with this, but I'm not going to. We're going to practice substitution. So start with your inside. That's usually a pretty good guess of what your u should be. Your inside is usually the u. All right, so we do take the derivative of it, and we get 4. And then we're going to solve for dx. So my dx is going to come over here. In this, I always put my 1/4 separate from my du. But if you put du over 4, that's fine. I'll end up doing that in a different problem just to show you that it's okay. But I divide by 4. I tend to just separate my du always, personally. All right, so there we go. Now, dx is by itself. We're going to do our 2 substitutions. So substitution 1 is the u. That's this piece right here. So we get that. Substitution number 2 is the dx. So that's this piece right here is going to go in for dx. Dx up there, we're going to replace it. We're going to replace it with 1/4 du, and everything's being multiplied, okay? So I'm going to pull my 1/4 out front. Problem's a lot easier now. Chain rule's gone. So you can even rewrite it one more time if you'd like, just so we can see the number of the power. So what do I do with the 1/4? Leave it. Good job there. All right. So I have my u. Lottie, what's the new power of u? 3/2. JP, what should I do with that 3/2? Divide by it. So instead of dividing by it, what am I going to do instead? Because it's a fraction. Multiply by the reciprocal. There it is. And then plus c. So what's my answer? 1/6. And instead of u, now we're going to go back, put my u back in. Let's see, minus 1 to the 3/2 plus c. Process is pretty simple, okay? The process isn't too bad. It's finding and trying to figure out what your u is that's actually harder, okay? So let's look at the next one. No problem. All right, so the next one, it says on top scalar multiples are okay. And I'm going to remind you after why it works. So remember when we did our chain rule? Our dn sat in front, right? Or sorry, in the back. We always multiplied by dn. So let's look at our inside here. I'm going to just put here. So my inside is 1 minus x squared. Well, my derivative of the inside would have been negative 2x. Scalars are okay. So what you're really going to look at, you need that function to be multiplied for the chain rule to have worked. Okay? If it was a chain rule, then the derivative of the inside should be multiplied by. Does that make sense to everyone? So, since I have this x, it's my hint to me that this is probably my u. Okay? And you'll see in a second why it works. All right, so there's my u. Step 2, take its derivative, which we just did a second ago. So I'm just going to copy that down. All right. Nathan, what's his next step? Solve for which one? dx. All right. So I'm going to move dx over here. I'm going to move the other thing down here. All right. I'm doing that all in one step for you. All right. Danny, what should I do now? Substitute. What would you like to substitute? Which one? You could just give me one of them. Which one you want to substitute? U? Alright, so let's go through. I'm going to come over here. So here's my u. Well, that's not u, so I'm just going to have to get stuck with that thing. And there's my u. Alright, David, what should I do now? So he wanted me to substitute in my u. Ooh, not yet. What's the other thing I have to substitute? Because he substituted the u. What's the other thing I have to substitute in? Not du, dx. This is the other piece, okay? So instead of dx, which is sitting right here, you're literally replacing that dx with the substitution. That. So I got negative 1 over 2x du. All right, we good so far? So what do you notice that happens with the x's? And this is being multiplied. They're canceling. That's why it works. That's why it works. So how do you know it doesn't work? How do you know you made a mistake? Here's how you'll know. You're going to have an x and a u in the problem, and they don't simplify out. You made a mistake is what it's screaming at you and telling you. Let's say you have du in your problem, in this step, but then you still have this x sitting here. You made a mistake. It will not work. If you do your substitution correctly, your x's should cancel out completely. There should be no x's left. Okay? So that's your hint. You made a mistake if there's x's and u's. You can't have both. All right, so what do we get here? I'm going to move this guy out front because it's ugly. I'm going to write this here and then write this here. Okay? I'm going to have to keep you guys for one quick second. I want to do one more. The other class, I didn't give them as much time on your quiz. All right, so let's see. So let's just write the answer. We get negative 1/2. I'm going to add 1 to u. Multiply by 2/3. And then plus c. So go ahead. You get negative. Oopsie, this way. Negative 1/3. U was 1 minus x squared to the 3/2 plus c. Okay? Good? Okay? So all I did was put the u back. You guys can finish that on your own. There's no need to copy. You can finish it on your own. All right. So this guy, tangent of x. We're doing the integral. Do you remember the problem we did cotangent? Our answer was cotangent. You're undoing that. So what do you think the first step is? Because it looks difficult right now. What's the first step? So when we change it. Yeah, you want to change it. Right now, you can't do any kind of substitution because you only have one function. There's only one function to deal with. So these that are fractions are also usually substitution. Your substitution will get the fraction to go away. So here's the question. Remember that your dn has to multiply. Okay? So, what's sine's derivative? Cosine. What's cosine's derivative? Negative sine. So both the functions are there. There is only one correct substitution. Only one of them will work. Remember your dn has to multiply. Who has to be the dn if it has to multiply? Wow, that did not come across at all. Do you guys see that cosine's on the bottom? What does this symbol mean? So when I read that, it says divide by cosine. So I'm going to say my statement one more time. Your dn has to be multiplied by. Who's the dn? Has to be sine. If you want your dn to be cosine, is it multiplied? No. So if you don't understand that, that's okay, because we're going to prove why it works. Huh? No, not yet. Hold on. So I want this to be dn. That means my u has to be the other function. And we're going to prove why it works. So derivative. Negative sine of x, just put down. And then solve for dx. Let's see. Don't want to do that. Okay. All right, so what do I do now? Because all I did was solve for my dx. Substitute u. So let's go through, substitute u. So u was supposed to be cosine. My dx is now negative 1 over sine of x. What happens to your sine of x? They cancel. If you tried it the other way, it won't work. If you don't believe me or you don't understand it, try to do your u as as sine. It won't work. You'll get stuck. It's because it's wrong. So now we end up with the integral of negative 1 over u du. Put the negative out. Whose derivative is 1 over u? ln. So negative ln, don't forget your absolute value, of u. What is u? Cosine. This is the physical rule for the integral of tangent. I have never memorized it in my life. I don't know what's wrong with me. I can't memorize it. I have to do this every time. Okay? Because it works. That, if you don't understand why u had to be cosine, try it with sine. You'll see why it doesn't work. Okay? All right. Sorry, guys. Didn't